Hello, my name is Brett Alger. I've worked for NOAA for the last 15 years, and for the last 7 years, I've worked in the Office of Science and Technology at headquarters. For about the last year, I've been working with Henry Milliken's gear research team at the Northeast Fisheries Science Center, and I'm here today to present on sort of some initial thoughts and ideas around developing interoperability standards to support an operational program. I'm not necessarily here to represent all of the agency, but really just offer my own personal perspective on some of the larger decision points to support an interoperable framework of systems and data. I'm focused on research to operations and thinking about an enterprise level system that is operationally efficient, reliable, but is also dynamic, that can accommodate new fishermen, new approaches, new companies, and can evolve over time. This is a slide that many of you have seen before. And really, the reflection here is just to point out that there's a number of different approaches to removing vertical lines from the water column. But I think a big part of transitioning to operations is education. And I think the loss of the surface buoy in response or subsequently to removing vertical lines is actually as much or more of a complex challenge in terms of developing the technological framework, the legal considerations, the policy considerations around creating a virtual gear marking system largely from scratch. And so to walk you through these kind of decision points, there's a series of diagrams or infographics that I'll walk through, and you'll see different points labeled on the screen. There'll be 8 of them, and at the end of the presentation, I'll sort of recap or summarize all those points. This first slide largely reflects the current phase of research in terms of single vessels acoustically communicating with single systems, as signified by the different vessels and the colors on the screen. And the first point that I want to make here is just to talk a little bit about enforcement. Generally, fixed gear enforcement is difficult. It can be resource intensive. And so, what we have started to hear from enforcement and think about is how are they in an operational program going to be efficiently able to detect, retrieve, inspect, and redeploy fishing gear. And so not only is that a technological set of considerations, but also in terms of what data they're going to need and how they're going to access it in order to do their patrols effectively. Another part of this is right now in the research phase, the fishing gear is deployed sort of manually. When gear goes into the water, there's a button push to signify where the gear is located. But there's also a component or a consideration that be done automatically. And there's a couple different reasons for that. One would be if gear goes into the water and somebody forgets to push a button, now there's gear in the water but no digital signature. Alternatively, if manual entry persists, you could have situations where people falsely set gear. In other words, they don't actually deploy the gear, but they create a digital signature. And that's a way to potentially hold bottom in terms of area conflict with fishermen. And so I think all of these different considerations impact software, hardware, and other parts of a functional system. This next diagram gets a bit more into the choices or the application of surface marking when the gear goes into the water versus the areas in the ocean where acoustic localization may be necessary. And this is a big part of what MITRE is working on, is to determine where acoustic localization is necessary and therefore may dictate one or more acoustic standards, as signified by now the multicolor display or symbols there going from each of the vessels. In other words, now each of those 3 vessels can more universally communicate across all the different fishing gear. This third slide starts to get a bit more into the different trade-offs of how gear can be detected. And so in one situation here on the left, you could have a scenario where the enforcement vessel and all the mobile vessels are outfitted with a through-hull transducer in order to detect the gear themselves. Versus, one of the other options that we're considering is, outfitting enforcement vessels, mobile vessels, and other ocean users with different cellular and satellite connectivity to be able to transmit the data to the vessel and have them display it on their chart plotter. I think another part of this also is thinking through the different data pathways to get the data from the vessel to, say, a data manager in terms of the data flow, either going through the gear manufacturer or around, say, the gear manufacturer directly to the data manager. And all those things need to be considered in terms of data security, data quality, etc. Item 4 starts to get a bit more into the data products that would be shared in real time. So, for example, if and once the data from the pink vessel, the orange vessel, and the yellow vessel, signified by the unicolor line, goes to the data manager in the cloud and it's integrated, well, those data products now can be shared back out to sea with all of those fixed gear fishermen, enforcement, and mobile vessels, as indicated by the colored rainbow of a line. And again, there's some legal issues and sort of policy issues to figure out in that space. But we're starting to learn a little bit more about the current capabilities, both in terms of data connectivity and visualization, and how to improve them to support something like this. And then thinking about a data manager, knowing that gear awareness now in fisheries is managed largely by line of sight, binoculars, radar, radio communications. I think the best way to sort of mimic that system is to potentially have a data manager that sits outside of the federal government or state agencies to kind of reduce the complexities around data privacy, data confidentiality, Magnuson-Stevens Act confidentiality provisions. In other words, those data transactions could happen outside of government to allow a more streamlined approach to authenticating users and implementing a rules-based approach to governance across all user groups, including data retention rules. This next slide is something many of you have seen before in past workshops and conversations, but it's really getting at two things. On the left, in terms of the rows that you see in the table, is thinking a bit around standardizing the actual data associated with on-demand fishing gear. And really the number 7 is more pointing out the sort of the columns, thinking about governance as to what types of data elements and data products the individual operators should have access to, enforcement, mobile vessels, gear manufacturers, fisheries managers, etc. And so this is where you start to hear people talk about should fishermen have a 5-mile radius in which they can see on-demand gear, 3-mile radius. Should you be able to see it shoreside? Do you have to be at sea? All those types of questions come up in sort of data governance. And I think it's a really important thing to put a plan together to support all of this. And then lastly, kind of the final piece of all this is once the data has been disseminated out to the vessels, is getting it visualized. And so one of our partners, Earth Ranger, has been building a mobile app called ER Buoy that is set to release soon, and we're hoping to get people testing that. But I think long-term, we've heard over and over that fishermen are going to want to have the data displayed on the systems that they're used to, their chart plotters. And so there's a lot of energy and urgency and collaboration happening between the gear manufacturers, chart plotting companies, and the National Marine Electronics Association to think about how to standardize the data associated with the gear and getting it into chart plotters for a long-term solution. And so this is essentially just a recap of all those stopping points in the visuals, and I'll just run through them quickly. So again, I think there's roughly eight. There's more, there's less, but I think these are the core 8 in terms of establishing the enforcement requirements to detect, retrieve, inspect, and redeploy, what types of data access and technology that enforcement is going to need, thinking about the standardization of underwater acoustics where it's necessary, and MITRE will be delivering an initial report to the agency in December. Thinking about the optimal modes of gear detection, thinking about data flows from the on-demand fishing gear to the cloud, thinking through cybersecurity and data integrity issues, identifying the current connectivity and visualization tools of the fishing vessels and trying to find those gaps and fill those in so that fishermen are capable of receiving and visualizing data long term. And I mentioned the buoy app that's getting released soon. Developing a third-party data manager that operates, implements sort of user authentication and a rules-based approach to governance. Establishing that sort of functional data specification associated with the fishing gear so that it can be more seamlessly integrated and shared across different systems. Creating that data governance framework. And then lastly, establishing a standard for chart plotter integration, which there was a workshop at the consortium to get that going. And so lastly, I want to thank you for your time and attention. I would certainly point you to the Northeast Fisheries Science Center Gear Library and their really great team. And certainly you can reach out to me anytime. Thank you.